Hi everyone, good morning. Like Today I would like to present Titanic survival prediction using data decision tree in Python. And my name is Vijendhar Reddy. The agenda for the presentation is overview of decision tree, which is like simple intuitive models that split decision based on future conditions to make predictions. And the next data set, we are taking the data set for like of Titanic passengers used to predict survival outcomes. It is basically predicting the survival outcome and feature selection like age, sex, P class, and fear to build decision tree and model training, demonstrating a model fitting using a SCI kit, Lunt's decision tree classifier, and lastly evaluation, which is more important of model performance metrics like accuracy and overfitting considerations. And coming to the overview of decision tree, like understanding the decision tree model using the Titanic data set, like what exactly the decision tree and why they are transparent, easy to visualize, and help derive insights from the data. They are particularly useful when interpretable is more important than model complexity. And in this, as like previously we discussed in the previous line, like these are the key topics here we are going to discuss on. And coming to the next slide, we are loading loading and exploring the Titanic data set. Like the right side, like there is a piece of code where we are loading the data set like train and test, which have the fields like passenger ID, survival, P class, name, sex, age, SCB, SIP, patch, ticket, fare, cabin, and embark. And like here, like later in the future slides, I'm going to explain about the code. I'm going to give a gist of the code, and later I will be explaining the full code. Like it is like loading the training and test data set from CSV file, and it also we are going to display only three rows of the training data set. Okay. And survived is our target variable, like binary is equals to 0, like binary 0 is equals to dead, 1 is equals to survived. Like it means whenever we see a 0, like we consider it as dead, and 1 is equals to survived. Some features like cabin and name contain textual data that needs to be processed. Missing data need to be handled, and categorical features need to be converted into numerical representation. And preparing the data for the model. So here in the slide, like this piece of code, it explains like we are preparing the data. Tells whether a passenger had a cabin on the Titan. This code, like has cabin, binary feature indicates if a passenger had a cabin. Feature group unknown uncommon titles under rare and map titles to numerical values, and mapped other categorical features like sex, embarked, fair, age into numerical categories. Final data set ready for analysis included features like survived, P class, sex, age, etc. And next, like handling age and titles. Extracted titles from the name columns to encode social status and relationship. Created a title feature by extracting titles from name and group unnamed titles in a rare category. Age grouping. Age grouping is like categorizing the age into groups to simplify the modeling and reduce the effects. And coming to the visualizing, like whatever we see on numbers, we are going to plot a diagram on this. Like this piece of code like gives heat map. Okay. And Gini. What exactly the Gini? The Gini index measures the probability of haphazardly pick a test being misclassified by a decision tree algorithm, and it values goes from 0 to 1. which zero indicates perfectly pure, one indicates perfectly impure. Zero Gini impurity and splitting category. Gini impurity measures the probability of misclassifying a random chosen element if it were labeled according to the class distribution. And in the right on the right hand side, like we have like I have mentioned a piece of code which the decision tree uses Gini impurity to decide the best feature for splitting. The function calculates Gini impurity based on the ratio of survived and not survived passengers. Okay, and finding out the optimal tree depth. Used k-fold cross validation with 10 splits for the find to optimal decision. Decision tree depth found that max depth as 3 and an average accuracy of 82%. And now I would like to walk through the code that I took it from the website. And initially, I have installed install the modules that are not existing before. So I have installed using pip library, like pip installed the two libraries I have installed, and I got some errors. Like I have upgraded the pip and reinstalled it. Okay, and then here we start the code. Like I am importing all the libraries. After installing, I'm importing all the libraries and modules into the code. There are different modules available for this. And here we are, like as I said previously, we are loading the data set here. And we are storing in the passenger ID, and we are displaying the three records. And just a minute, I run this. Yeah, here we see, like uh, here we are displaying the three records. And in the next piece of code, like there is like what do you say, original train, and we are referring here, and we are removing all nulls, and we are grouping the data, and here we are grouping the data, and like mapping everything here, and I'm again running this piece of code. Here you see the train head 3 data, and this is a map that which I have discussed in the presentation. This is a person correlation of features, like the rows describe survived P class, and that one. This is a ratio from 0 to the 1, and this is a survived in a binary class 0. These metrics grouped by the title feature representation, and this is a table for that. And this is a train like 6 and survive. This is a mean like 0.742038, and count is 314. And for one which indicates male, so which represents point 188,908. Okay, then we are data framing to check the sex distribution for each title. So here we are representing the mean mean count and sum. Here is a few details of that. Like depends on the title, what is exactly mean and count for that. And next here this is related to the Gini impurity, which we have discussed in the slide. uh, and it got the Gini impurity, we got it like 0.743, which is good. Like for the node for male observations, it is 0.036, and for the female we got like 0.3828, and Gini impurity decrease if node splitted by 6, like it is minus 0.13964. If you observe, if for the node for observations with the title 1 is 1, which represents a male, like 0.264, and for female 0.4217. And this is a K fold, but this is a K fold, like which is cross validation fold. Like we have depth, average, and accuracy for given 1 to 10. Like we have different accuracies here, and then um, the final tree, like which I would like to discuss here. Like this is a final tree that given, like the final result, the decision tree. Here we here we have the decision tree. It achieves an accuracy of 82.38 percentage across the training data sets. Okay, like it has the title, genie, samples, value, and class. So the decision tree, if the true, like it goes has cabin, family size, and if again it is divided into has, it has cabin is divided into P class and fare, depends on the fare. It is again divided into genie and genie sample values, like different genie values, and class date. Like here we have survived one. For the survived one, values are different. For this different. And coming to the next slide, like for the above presentation, if you have any questions, like post down this video or reply to this video. um Thank you for watching my presentation.